I've earned 30 plus certifications, and I'm here to guide you to success on your exam. Welcome to the Ultimate AIP C01 Exam Masterclass. Are you ready to crack the AIP C01 exam in one go? You're in the right place. In this session, we'll arm you with powerful insights and hand-picked questions that can make all the difference in your exam performance. We've scanned the web using intelligent crawlers to gather the most critical and high-impact questions, all compiled into one powerful PDF resource. You can download it from the link in the description. Not only will we explore these must-practice questions, but we'll also share real exam experiences and pro tips to give you that competitive edge. Let's dive into the key questions that could shape your success. Question 1. A financial services company is creating a retrieval augmented generation (RAG) application that uses Amazon Bedrock to generate summaries of market activities. The application relies on a vector database that stores a small proprietary dataset that has a low index count. The application must perform similarity searches. The Amazon Bedrock model's responses must maximize accuracy and maintain high performance. The company needs to configure the vector database and integrate it with the application. Which solution will meet these requirements? A. Launch an Amazon MemoryDB cluster and configure the index by using the flat algorithm. Configure a horizontal scaling policy based on performance metrics. B. Launch an Amazon MemoryDB cluster and configure the index by using the hierarchical navigable small world (HNSW) algorithm. Configure a vertical policy based on performance metrics. C. Launch an Amazon Aurora PostgreSQL cluster and configure the index by using the inverted file with flat compression (IVF flat) algorithm. Configure the instance class to scale to a larger size when the load increases. D. Launch an Amazon DocumentDB cluster that has an inverted file with flat compression (IVF flat) index and a high probe value. Configure connections to the cluster as a replica set distribute reads to replica instances. Correct answer A. Launch an Amazon MemoryDB cluster and configure the index by using the flat algorithm. Configure a horizontal scaling policy based on performance metrics. Explanation: small dataset requires exact similarity search. Flat index provides highest accuracy. MemoryDB vector search works efficiently without approximate algorithms. Question 2. A company has deployed an AI assistant as a React application that uses AWS Amplify, an AWS AppSync GraphQL API, and Amazon Bedrock knowledge bases. The application uses the GraphQL API to call the Amazon Bedrock Retrieve and Generate API for knowledge base interactions. The company configures an AWS Lambda resolver to use the request-response invocation type. Application users report frequent timeouts and slow response times. Users report these problems more frequently for complex questions that require longer processing. The company needs a solution to fix these performance issues and enhance the user experience. Which solution will meet these requirements? A. Use AWS Amplify AI Kit to implement streaming responses from the GraphQL API and to optimize client-side rendering. B. Increase the timeout value of the Lambda resolver. Implement retry logic with exponential backoff. C. Update the application to send an API request to an Amazon SQS queue. Update the AWS AppSync resolver to poll and process the queue. D. Change the Retrieve and Generate API to the Invoke model with Response Stream API. Update the application to use an Amazon API Gateway WebSocket API to support the streaming response. Correct answer A. Use AWS Amplify AI Kit to implement streaming responses from the GraphQL API and to optimize client-side rendering. Explanation: streaming responses reduce perceived latency. Amplify AI Kit allows partial output rendering while Bedrock processes complex queries. Question 3. An e-commerce company operates a global product recommendation system that needs to switch between multiple foundation models, FM, and Amazon Bedrock based on regulations, cost optimization, and performance requirements. The company must apply custom controls based on proprietary business logic, including dynamic cost thresholds, AWS region-specific compliance rules, and real-time A/B testing across multiple FMs. The system must be able to switch between FMs without deploying new code. The system must route user requests based on complex rules including user tier, transaction value, regulatory zone, and real-time cost metrics that change hourly and require immediate propagation across thousands of concurrent requests. Which solution will meet these requirements? A. Deploy an AWS Lambda function that uses environment variables to store routing rules and Amazon Bedrock FM IDs. Use the Lambda console to update the environment variables when business requirements change. Configure an Amazon API Gateway REST API to read request parameters to make routing decisions. B. Deploy Amazon API Gateway REST API request transformation templates to implement routing logic based on request attributes. Store Amazon Bedrock FM endpoints as REST API stage variables. Update the variables when the system switches between models. C. Configure an AWS Lambda function to fetch routing configurations from the AWS AppConfig agent for each user request. Run business logic in the Lambda function to select the appropriate FM for each request. Expose the FM through a single Amazon API Gateway REST API endpoint. D. Use AWS Lambda authorizers for an Amazon API Gateway REST API to evaluate routing rules that are stored in AWS AppConfig. Return authorization contexts based on business logic. Route requests to model-specific Lambda functions for each Amazon Bedrock FM. Correct answer, C. Configure an AWS Lambda function to fetch routing configurations from the AWS AppConfig agent for each user request. Run business logic in the Lambda function to select the appropriate FM for each request. Expose the FM through a single Amazon API Gateway REST API endpoint. Explanation: AWS AppConfig dynamic configuration allows rule updates without redeployment. Lambda evaluates routing logic and selects Bedrock models dynamically. Question 4. A financial services company is building a customer support application that retrieves relevant financial regulation documents from a database based on semantic similarities to user queries. The application must integrate with Amazon Bedrock to generate responses. The application must be able to search documents that are in English, Spanish, and Portuguese. The application must filter documents by metadata such as publication date, regulatory agency, and document type. The database stores approximately 10 million document embeddings. To minimize operational overhead, the company wants a solution that minimizes management and maintenance effort. The application must provide low-latency responses for real-time customer interactions. Which solution will meet these requirements? A. Use Amazon OpenSearch Serverless to provide vector search capabilities and metadata filtering. Connect to Amazon Bedrock knowledge bases to enable retrieval-augmented generation (RAG) capabilities that use an Anthropic Cloud Foundation model (FM). B. Deploy an Amazon Aurora PostgreSQL database with the vector extension. Define tables to store embeddings and metadata. Use SQL queries to perform similarity searches. Send retrieved documents to Amazon Bedrock to generate responses. C. Use Amazon S3 vectors to configure a vector index and non-filterable metadata fields. Integrate S3 vectors with Amazon Bedrock to enable retrieval-augmented generation (RAG) capabilities. D. Set up an Amazon Neptune Analytics graph database. Configure a vector index that has appropriate dimensionality to store document embeddings. Use Amazon Bedrock to perform graph-based retrieval and to generate responses. Correct answer A. Use Amazon OpenSearch Serverless to provide vector search capabilities and metadata filtering. Connect to Amazon Bedrock knowledge bases to enable retrieval-augmented generation (RAG) capabilities that use an Anthropic Cloud Foundation model (FM). Explanation: OpenSearch Serverless vector search supports embeddings and metadata filtering while integrating easily with Bedrock knowledge bases. Question 5. A medical company is building a generative AI, Gen AI, application that uses RAG to provide evidence-based medical information. The application uses Amazon OpenSearch service to retrieve vector embeddings. Users report that searches frequently miss results that contain exact medical terms and acronyms and return too many semantically similar but irrelevant documents. The company needs to improve retrieval quality and maintain low end-user latency, even as the document collection grows to millions of documents. Which solution will meet these requirements with the least operational overhead? A. Configure hybrid search by combining vector similarity with keyword matching to improve semantic understanding and exact term and acronym matching. B. Increase the dimensions of the vector embeddings from 384 to 1536. Use a post-processing AWS Lambda function to filter out irrelevant results after retrieval. C. Replace OpenSearch service with Amazon Kendra. Use query expansion to handle medical acronyms and terminology variants during pre-processing. D. Implement a two-stage retrieval architecture in which initial vector search results are re-ranked by an ML model that is hosted on Amazon SageMaker AI. Correct answer A. Configure hybrid search by combining vector similarity with keyword matching to improve semantic understanding and exact term and acronym matching. Explanation: hybrid search, vector plus keyword, improves retrieval accuracy for medical acronyms and exact terminology while keeping low latency. Question 6. A media company must use Amazon Bedrock to implement a robust governance process for AI-generated content. The company needs to manage hundreds of prompt templates. Multiple teams use the templates across multiple AWS regions to generate content. The solution must provide version control with approval workflows that include notifications for pending reviews. The solution must also provide detailed audit trails that document prompt activities and consistent prompt parameterization to enforce quality standards. Which solution will meet these requirements? A. Configure Amazon Bedrock Studio prompt templates. Use Amazon CloudWatch to create dashboards that display prompt usage metrics. Store the approval status of content in Amazon DynamoDB. Use AWS Lambda functions to enforce approvals. B. Use Amazon Bedrock Prompt Management to implement version control. Configure AWS CloudTrail for audit logging. Use IAM policies to control approval permissions. Create parameterized prompt templates by specifying variables. C. Use AWS step functions to create an approval workflow. Store prompts as documents in Amazon S3. Use tags to implement version control. Use Amazon EventBridge to send notifications. D. Deploy Amazon SageMaker Canvas with prompt templates that are stored in Amazon S3. Use AWS CloudFormation to implement version control. Use AWS config to enforce approval policies. Correct answer B. Use Amazon Bedrock Prompt Management to implement version control. Configure AWS CloudTrail for audit logging. Use IAM policies to control approval permissions. Create parameterized prompt templates by specifying variables. Explanation: Bedrock Prompt Management supports prompt versioning, approval workflows, and parameterized templates with CloudTrail auditing. Question 7. A company is developing a customer support application that uses Amazon Bedrock Foundation Models, FMs, to provide real-time AI assistance to the company's employees. The application must display AI-generated responses character by character as the responses are generated. The application needs to support thousands of concurrent users with minimal latency. The responses typically take 15 to 45 seconds to finish. Which solution will meet these requirements? A. Configure an Amazon API Gateway WebSocket API with an AWS Lambda integration. Configure the WebSocket API to invoke the Amazon Bedrock Invoke model with Response Stream API and stream partial responses through WebSocket connections. B. Configure an Amazon API Gateway REST API with an AWS Lambda integration. Configure the REST API to invoke the Amazon Bedrock Standard Invoke Model API and implement front-end client-side polling every 100 milliseconds for complete response chunks. C. Implement direct front-end client connections to Amazon Bedrock by using IAM user credentials and the Invoke Model with Response Stream API without any intermediate gateway or proxy layer. D. Configure an Amazon API Gateway HTTP API with an AWS Lambda integration. Configure the HTTP API to cache complete responses in an Amazon DynamoDB table and serve the responses through multiple paginated GET requests to front-end clients. Correct answer A. Configure an Amazon API Gateway WebSocket API with an AWS Lambda integration. Configure the WebSocket API to invoke the Amazon Bedrock Invoke Model with Response Stream API and stream partial responses through WebSocket connections. Explanation: Invoke Model with Response streams tokens as generated. WebSocket API delivers real-time responses to thousands of concurrent users. Question 8. A healthcare company is using Amazon Bedrock to build a Retrieval Augmented Generation (RAG) application that helps practitioners make clinical decisions. The application must achieve high accuracy for patient information retrievals, identify hallucinations in generated content, and reduce human review costs. Which solution will meet these requirements? A. Use Amazon Comprehend to analyze and classify RAG responses and to extract medical entities and relationships. Use AWS step functions to orchestrate automated evaluations. Configure Amazon CloudWatch metrics to track entity recognition confidence scores. Configure CloudWatch to send an alert when accuracy falls below specified thresholds. B. Implement automated large language model (LLM) based evaluations that use a specialized model that is fine-tuned for medical content to assess all responses. Deploy AWS Lambda functions to parallelize evaluations. Publish results to Amazon CloudWatch metrics that track relevance and factual accuracy. C. Configure Amazon CloudWatch synthetics to generate test queries that have known answers on a regular schedule, and track model success rates. Set up dashboards that compare synthetic test results against expected outcomes. D. Deploy a hybrid evaluation system that uses an automated LLM as a judge evaluation to initially screen responses and targeted human reviews for edge cases. Use Amazon SageMaker Feature Store to maintain evaluation datasets. Use a built-in Amazon Bedrock evaluation to track retrieval precision and hallucination rates. Correct answer D. Deploy a hybrid evaluation system that uses an automated LLM as a judge evaluation to initially screen responses and targeted human reviews for edge cases. Use Amazon SageMaker Feature Store to maintain evaluation datasets. Use a built-in Amazon Bedrock evaluation to track retrieval precision and hallucination rates. Explanation: LLM as judge evaluation with human review detects hallucinations effectively while reducing manual validation costs. Question 9. An e-commerce company is developing a generative AI, Gen AI, solution that uses Amazon Bedrock with Anthropic Claude to recommend products to customers. Customers report that some of the recommended products are not available for sale on the website or are not relevant to the customer. Customers also report that the solutions takes a long time to generate some recommendations. The company investigates the issues and finds that most interactions between customers and the product recommendation solution are unique. The company confirms that the solutions recommends products that are not in the company's product catalog. The company must resolve these issues. Which solution will meet this requirement? A. Increase grounding within Amazon Bedrock guardrails. Enable automated reasoning checks. Set up provision throughput. B. Use prompt engineering to restrict the model responses to relevant products. Use streaming techniques such as the Invoke Model with Response Stream action to reduce perceived latency for the customers. C. Create an Amazon Bedrock knowledge base. Implement Retrieval Augmented Generation (RAG). Set the performance config latency parameter to optimized. D. Store product catalog data in Amazon OpenSearch service. Validate the model's product recommendations against the product catalog. Use Amazon DynamoDB to implement response caching. Correct answer, C. Create an Amazon Bedrock knowledge base. Implement Retrieval Augmented Generation (RAG). Set the performance config latency parameter to optimized. Explanation: RAG with Bedrock knowledge base grounds responses in the product catalog, preventing hallucinated recommendations and improving relevance. Question 10. A healthcare company uses Amazon Bedrock to deploy an application that generates summaries of clinical documents. The application experiences inconsistent response quality with occasional factual hallucinations. Monthly costs exceed the company's projections by 40%. A Gen AI developer must implement a near real-time monitoring solution to detect hallucinations, identify abnormal token consumption, and provide early warnings of cost anomalies. The solution must require minimal custom development work and maintenance overhead. Which solution will meet these requirements? A. Configure Amazon CloudWatch alarms to monitor input token count and output token count metrics to detect anomalies. Store model invocation logs in an Amazon S3 bucket. Use AWS Glue and Amazon Athena to identify potential hallucinations. B. Run Amazon Bedrock evaluation jobs that use LLM-based judgments to detect hallucinations. Configure Amazon CloudWatch to track token usage. Create an AWS Lambda function to process CloudWatch metrics. Configure the Lambda function to send usage pattern notifications. C. Configure Amazon Bedrock to store model invocation logs in an Amazon S3 bucket. Enable text output logging. Configure Amazon Bedrock guardrails to run contextual grounding checks to detect hallucinations. Create Amazon CloudWatch anomaly detection alarms for token usage metrics. D. Use AWS CloudTrail to log all Amazon Bedrock API calls. Create a custom dashboard in Amazon QuickSight to visualize token usage patterns. Use Amazon SageMaker Model Monitor to detect quality drift in generated summaries. Correct answer: C. Configure Amazon Bedrock to store model invocation logs in an Amazon S3 bucket. Enable text output logging. Configure Amazon Bedrock guardrails to run contextual grounding checks to detect hallucinations. Create Amazon CloudWatch anomaly detection alarms for token usage metrics. Explanation: Bedrock logging and guardrails grounding checks detect hallucinations. CloudWatch anomaly detection monitors token usage and cost spikes. Question 11. A company is building a generative AI, Gen AI, application that produces content based on a variety of internal and external data sources. The company wants to ensure that the generated output is fully traceable. The application must support data source registration and enable metadata tagging to attribute content to its original source. The application must also maintain audit logs of data access and usage throughout the pipeline. Which solution will meet these requirements? A. Use AWS Lake Formation to catalog data sources and control access. Apply metadata tags directly in Amazon S3. Use AWS CloudTrail to monitor API activity. B. Use AWS Glue Data Catalog to register and tag data sources. Use Amazon CloudWatch logs to monitor access patterns and application behavior. C. Store data in Amazon S3 and use object tagging for attribution. Use AWS Glue Data Catalog to manage schema information. Use AWS CloudTrail to log access to S3 buckets. D. Use AWS Glue Data Catalog to register all data sources. Apply metadata tags to attribute data sources. Use AWS CloudTrail to log access and activity across services. Correct answer: D. Use AWS Glue Data Catalog to register all data sources. Apply metadata tags to attribute data sources. Use AWS CloudTrail to log access and activity across services. Explanation: Glue Data Catalog registers and tags data sources while CloudTrail logs access activities, ensuring traceability and auditing. Question 12. A financial services company needs to build a document analysis system that uses Amazon Bedrock to process quarterly reports. The system must analyze financial data, perform sentiment analysis, and validate compliance across batches of reports. Each batch contains 5 reports. Each report requires multiple foundation model (FM) calls. The solution must finish the analysis within 10 seconds for each batch. Current sequential processing takes 45 seconds for each batch. Which solution will meet these requirements? A. Use AWS Lambda functions with provisioned concurrency to process each analysis type sequentially. Configure the Lambda function timeouts to 10 seconds. Configure automatic retries with exponential backoff. B. Use AWS step functions with a parallel state to invoke separate AWS Lambda functions for each analysis type simultaneously. Configure Amazon Bedrock client timeouts. Use Amazon CloudWatch metrics to track execution time and model inference latency. C. Create an Amazon SQS queue to buffer analysis requests. Deploy multiple AWS Lambda functions with reserved concurrency. Configure each Lambda function to process different aspects of each report sequentially, and then combine the results. D. Deploy an Amazon ECS cluster that runs containers that process each report sequentially. Use a load balancer to distribute batch workloads. Configure an auto-scaling policy based on CPU utilization to handle demand fluctuations. Correct answer B. Use AWS step functions with a parallel state to invoke separate AWS Lambda functions for each analysis type simultaneously. Configure Amazon Bedrock client timeouts. Use Amazon CloudWatch metrics to track execution time and model inference latency. Explanation: Step functions parallel state executes multiple analysis tasks concurrently, significantly reducing batch processing time. Question 13. A company is using Amazon Bedrock to build a customer-facing AI assistant to handle sensitive customer inquiries. The company must use defense-in-depth safety controls to block sophisticated prompt injection attacks. The company must keep audit logs of all safety interventions. The AI assistant must have cross-region failover capabilities. Which solution will meet these requirements? A. Configure Amazon Bedrock guardrails to use content filters to protect against prompt injection attacks. Set the content filters to high. Use a guardrail profile to implement cross-region guardrail inference. Use Amazon CloudWatch logs with custom metrics to capture detailed guardrail intervention events. B. Configure Amazon Bedrock guardrails to use content filters to protect against prompt injection attacks. Set the content filters to high. Use AWS WEF to block suspicious inputs. Use AWS CloudTrail to log API calls for audits. C. Deploy Amazon Comprehend custom classification to detect prompt injection attacks. Use Amazon API Gateway to validate requests. Use Amazon CloudWatch logs with custom metrics to capture detailed intervention events. D. Configure Amazon Bedrock guardrails to use custom content filters to protect against harmful content. Set the content filters to high. Use word filters to protect against known attack patterns. Configure cross-region guardrail replication to provide failover capabilities. Store logs in AWS CloudTrail for compliance auditing. Correct answer B. Configure Amazon Bedrock guardrails to use content filters to protect against prompt injection attacks. Set the content filters to high. Use AWS WEF to block suspicious inputs. Use AWS CloudTrail to log API calls for audits. Explanation: Bedrock guardrails plus AWS WEF protect against prompt injection and malicious inputs, while CloudTrail maintains audit logs. Question 14. A financial services company uses an AI application to process financial documents by using Amazon Bedrock. During business hours, the application handles approximately 10,000 requests each hour, which requires consistent throughput. The company uses the Create Provision Model Throughput API to purchase provision throughput. Amazon CloudWatch metrics show that the provision capacity is unused while on-demand requests are being throttled. The company finds the following code in the application: Python response equals bedrock_runtime.invoke_model, model ID equals anthropic.claude v2, body equals json.dumps payload. The company needs the application to use the provisioned throughput and to resolve the throttling issues. Which solution will meet these requirements? A. Increase the number of model units MUs in the provisioned throughput configuration. B. Replace the model ID parameter with the ARN of the provisioned model that the create provision model throughput API returns. C. Add exponential backoff retry logic to handle throttling exceptions during peak hours. D. Modify the application to use the invoke model with response stream API instead of the invoke model API. Correct answer B. Replace the model ID parameter with the ARN of the provisioned model that the create provision model throughput API returns. Explanation: applications must use the provisioned throughput model ARN, not the base model ID, to consume purchase capacity. Question 15. A company is building an AI advisory application by using Amazon Bedrock. The application will provide recommendations to customers. The company needs the application to explain its reasoning process and cite specific sources for data. The application must retrieve information from company data sources and show step-by-step reasoning for recommendations. The application must also link data claims to source documents and maintain response latency under 3 seconds. Which solution will meet these requirements with the least operational overhead? A. Use Amazon Bedrock knowledge bases with source attribution enabled. Use the Anthropic Claude Messages API with RAG to set high relevance thresholds for source documents. Store reasoning and citations in Amazon S3 for auditing purposes. B. Use Amazon Bedrock with Anthropic Claude models and extended thinking. Configure a 4,000 token thinking budget. Store reasoning traces and citations in Amazon DynamoDB for auditing purposes. C. Configure Amazon SageMaker AI with a custom Anthropic Claude model. Use the model's reasoning parameter and AWS Lambda to process responses. Add source citations from a separate Amazon RDS database. D. Use Amazon Bedrock with Anthropic Claude models and chain of thought reasoning. Configure custom retrieval tracking with the Amazon Bedrock Knowledge Bases API. Use Amazon CloudWatch to monitor response latency metrics. Correct answer A. Use Amazon Bedrock Knowledge Bases with source attribution enabled. Use the Anthropic Claude Messages API with RAG to set high relevance thresholds for source documents. Store reasoning and citations in Amazon S3 for auditing purposes. Explanation: Bedrock knowledge bases with source attribution provide citations and explainable answers using RAG with minimal operational effort. Question 16. A retail company is developing a customer service application that must process 10,000 daily queries about products, orders, and warranties. The application must be able to respond to queries about 50,000 product documents that are updated every day. The application must integrate with an order management API to check the status of orders and to help process returns. The application must maintain context throughout multi-turn interactions with customers. The company must collect complete audit trails for application responses. Which solution will meet these requirements with the least operational overhead? A. Deploy a fine-tuned Amazon Bedrock Anthropic Claude model for each product category. Create AWS Lambda functions to connect each model to the Order Management API. Store conversation history in Amazon DynamoDB. B. Create a custom model that uses continued pre-training on Amazon Bedrock to handle all product documentation. Set up an Amazon API Gateway REST API that uses AWS Lambda functions to connect the model to the Order Management API. C. Use Amazon SageMaker AI with containers to deploy models. Use Amazon Kendra to search product documents. Use AWS Step functions to orchestrate calls to the Order Management API. D. Use an Amazon Bedrock agent with action groups to integrate with the Order Management API. Associate an Amazon Bedrock knowledge base with the agent to search product documentation by using Retrieval Augmentation Generation (RAG). Enable trace events to capture audit trails. Correct answer D. Use an Amazon Bedrock agent with action groups to integrate with the Order Management API. Associate an Amazon Bedrock knowledge base with the agent to search product documentation by using Retrieval Augmentation Generation (RAG). Enable trace events to capture audit trails. Explanation: Bedrock agents integrate APIs through action groups and retrieve documents from knowledge bases while maintaining conversation context. Question 17. A company is developing a generative AI, Gen AI, application that analyzes customer service calls in real time and generates suggested responses for human customer service agents. The application must process 500,000 concurrent calls during peak hours with less than 200 milliseconds end-to-end latency for each suggestion. The company uses existing architecture to transcribe customer call audio streams. The application must not exceed a predefined monthly compute budget and must maintain auto-scaling capabilities. Which solution will meet these requirements? A. Deploy a large, complex reasoning model on Amazon Bedrock. Purchase provision throughput and optimize for batch processing. B. Deploy a low-latency, real-time optimized model on Amazon Bedrock. Purchase provision throughput and set up automatic scaling policies. C. Deploy a large language model, LLM, on an Amazon SageMaker AI real-time endpoint that uses dedicated GPU instances. D. Deploy a mid-sized language model on an Amazon SageMaker AI serverless endpoint that is optimized for batch processing. Correct answer B. Deploy a low-latency, real-time optimized model on Amazon Bedrock. Purchase provision throughput and set up automatic scaling policies. Explanation: Low-latency Bedrock models with provision throughput support high concurrency and meet strict real-time latency requirements. Question 18. A healthcare company is using Amazon Bedrock to build a system to help practitioners make clinical decisions. The system must provide treatment recommendations to physicians based only on approved medical documentation and must cite specific sources. The system must not hallucinate or produce factually incorrect information. Which solution will meet these requirements with the least operational overhead? A. Integrate Amazon Bedrock with Amazon Kendra to retrieve approved documents. Implement custom post-processing to compare generated responses against source documents, and to include citations. B. Deploy an Amazon Bedrock knowledge base and connect it to approved clinical source documents. Use the Amazon Bedrock Retrieve and Generate API to return citations from the knowledge base. C. Use Amazon Bedrock and Amazon Comprehend Medical to extract medical entities. Implement verification logic against a medical terminology database. D. Use an Amazon Bedrock knowledge base with Retrieve API calls and Invoke Model API calls to retrieve approved clinical source documents. Implement verification logic to compare against retrieved sources and to cite sources. Correct answer B. Deploy an Amazon Bedrock knowledge base and connect it to approved clinical source documents. Use the Amazon Bedrock Retrieve and Generate API to return citations from the knowledge base. Explanation: Retrieve and Generate API with Bedrock knowledge base ensures responses come only from approved documents with automatic citations. Question 19. A company has set up Amazon Q Developer Pro licenses for all developers at the company. The company maintains a list of approved resources that developers must use when developing applications. The approved resources include internal libraries, proprietary algorithmic techniques, and sample code with approved styling. A new team of developers is using Amazon Q Developer to develop a new Java-based application. The company must ensure that the new developer team uses the company's approved resources. The company does not want to make project-level modifications. Which solution will meet these requirements? A. Create a Git repository that contains all of the approved internal libraries, algorithms, and code samples. Include this Git repository in the application project locally as part of the workspace. Ensure that the developers use the @workspace context to retrieve suggestions from the Git repository. B. In the project root folder, create a folder named .amazon/rules. Add the approved internal libraries, algorithms, and code samples to the folder. C. Create a folder in the application project named rules. Store the guidelines and code in the folder for Amazon Q Developer to reference product code suggestions. D. Create an Amazon Q Developer customization that includes the approved data sources. Ensure that the developers use the customization to develop the application. Correct answer D. Create an Amazon Q Developer customization that includes the approved data sources. Ensure that the developers use the customization to develop the application. Explanation: Amazon Q Developer customization enforces company-approved resources globally without modifying each project workspace. Question 20. An e-commerce company is using Amazon Bedrock to build a customer service AI assistant. The AI assistant needs to process over 50,000 customer inquiries every day. The AI assistant occasionally experiences traffic spikes of up to 150,000 inquiries every day during promotional events. Analysis shows that 40% of inquiries follow similar patterns that share the same context. A Gen AI developer must design a solution that will ensure low latency and consistent performance for the AI assistant during traffic spikes. Which solution will meet these requirements most cost-effectively? A. Configure latency-optimized inference by setting the latency parameter to optimized in the performance configuration of the request to Amazon Bedrock. Use prompt caching to handle the repetitive inquiries. B. Purchase provisioned throughput and model units MUs that are sized to handle peak traffic loads. Use Amazon Elasticache, Redis OSS, to cache repetitive inquiries. C. Use Amazon Bedrock agents and custom knowledge bases to preprocess customer inquiries. Configure cross-region inference to distribute traffic. D. Use AWS Lambda functions to preprocess requests by using a custom prompt routing mechanism. Use Amazon DynamoDB as a caching layer to handle frequently asked questions. Correct answer A. Configure latency-optimized inference by setting the latency parameter to optimized in the performance configuration of the request to Amazon Bedrock. Use prompt caching to handle the repetitive inquiries. Explanation: Prompt caching handles repetitive queries while latency-optimized inference improves response speed during traffic spikes. Please revise full PDF 2 to 3 times for 100% success. Check the description for the PDF download link and don't forget to subscribe to this channel for upcoming episodes. Thank you.